Hello everyone. So this session we go to a very big section. Let's start from here. We will go to trigonometry. Trigonometry is a very important part in the mathematics, right? It's deal with the angle. Deal with the angle. If you're still familiar, sine, cosine, right? Tangent, cotangent. So that's what we learned about that. Okay. Um, it's trigonometry is a part of the analytical geometry. Okay, so but everything that start from the base. So the base we have some concept. First is the uh, angles in the unit circle. Okay, what's that mean? So first, let's look at this circle. Okay, the unit circle we have made as one. What's mean that? So we call 1 degree is a whole circle. Okay, 1 degree is a whole circle. Sometimes it's very hard to understand. Sometimes I just use the hour compare with the watch. So it's like a 1 hour is uh, uh is it's not hour. Uh, it's uh, it's like 24 hour, right, in the clock, right? So it's like this way. Okay. Uh, now we have another small unit uh, we call minute. We call minute. 1 minute is 1/60 of the uh, degree, 1 degree. And there's another more smaller we call second. So you think about the second, minute, an hour, right? Definitely everyone have a 60 over 1, right? So becomes smaller and smaller. So give an example, we just writing simply as 1 wait, as 1 degree equals to 60 minutes equals to 3600 seconds. So we can write it like this way. So let's do a simple example of exercises. If we have 10 degree, 10 minutes, 10 seconds, I will ask you how many degree it is. So definitely 10 degree we don't need to, it's already there, right? So plus is what? 10 seconds is 10 over 60, right? And plus 10 minutes, sorry. 10 seconds is 10 over 36,000, right? So if they plus together is the degree. Vice versa, if I ask you how many seconds it is, so you will times 60 times 3,600. This minutes will times 60, right? So we will get it. This is the first concept. The second concept is regarding radian. Let's make it bigger. This is a important concept. Okay. What is radian? Radian to me, okay, I think people, to me is I more looks like radian as an arc. Uh, think about what this angle is really like. Angle is like a like a line. Will start from the horizontal, and as the line have a center here, based on the center, the another side of the line just raise up, right? So when they raise to like the data, like this angle, so we call the angle here. We call that they have angle here, like a 35 degree or something. But they also we have called a radian. A radian to me is more like I treat it as an arc, but it have some special. It's based on we treat this radius as one as a unit one. So think about that. The whole circle, the radian is 2 pi r, right? If one is r, so the whole radian of a circle is 2 pi, right? So the radian of an angle is can translate it to be the pi, right? Something like that. So you think about like 360 is one circle, right? 360 degree equals to what? 360 degree is equal to 2 pi, right? So pi is equal to 180 degree, right? So if I told you the radian is pi over 4, so the corresponding angle is 45 degree. Am I right? So this is the radian. Okay, let's see another concept. Uh, okay, so okay, this can be a little example about that. For this angle data, okay, the data sometimes I'm weak. I use this one. This angle equals to what? 120 degree. So what's the radian? Radian of the data is equals to what? 120. How to transform? Because there will be get pi. So pi over 180, right? So equals to 3 over 2 pi. Just like that easy. Okay. So let's go to another concept. Arc length. Arc length, in fact, as I already introduced the radian, so you quite easy to understand, right? So this exactly as the another side of the angle, another line go to angle of A, then the way that it should walk, the length here, the arc we call S, is the length of the arc. The length of arc equals to RA. R is radius. A is not angle. A here. A is the we just already learned is radian. Okay. A here is radian. So let me change here. Here should be radian. Okay. A here should be radian. So how we come like this way? Just think about that. The whole circle the whole circle the length is like 2 pi r. Am I right? 2 pi r. Okay. So if you are 2 pi is the radian, right? 2 pi r, right? So if the uh so if you just have the angle, if your radian is only a, so of course your curve, your arc length is a times r, right? A definitely is a kind of expression by pi. Am I right? Okay. Okay, let's pass on this. We give some example to understand this. Anyway, today is more on concept, so somehow it's a little boring. So okay. So the example is find the length of the arc of a circle with a radius is they talk about radius here, so 20 centimeters, and the angle is 45. The angle is right about. So so first we saw this is the formula, right? But we the information that we get is angle. The angle, right, is 45 degree. And now we need to get the what? We need to get radian, right? Is equals to what? 45 degree times what? 180 divided by, sorry, pi divided by 180. So equals to pi over 4. So since we already got all the data that we needed, so the length of the arc is like 20 times pi over 4. So 5 pi, the unit cm, right? So the length of the arc is 5 pi cm. One last conception we call coterminal angle. Why call coterminals? First thing about terminal. The first thing about what is angle it is. The angle is have a two line with the same center, right? The start at the horizontal, but anyway, you can start at other not horizontal, it's also okay. But right now we just think about it, start from horizontal. The line, okay, from the x-axis, and then another line is raised up by the center of the axis, when they raise to the angle of A, they form the angle of A. They also form the radian, right? Radian is pi over 3, pi over 3, right? If the angle is 60. Okay, but we know that this line, the second line, can be keep on moving, right? And if you're going on here, there's a big angle, right? They're over 90, right? If I'm going here, up here is more than 180. If I'm up here is more than 270, right? How about if go back again, get one circle? It's okay, it still count, right? But when they move up again, they go to the state at the same point. So here we call co-angle, co-terminal angles. Even they pass through one or more circles but stay at the same point in a circle. So we call that co-terminal angles. So I'll give you an example. If the angle A here is the 60, what's the co-terminal angles? How many of them? First, unlimited, right? Because they can keep on have different kind of circles, so many circles. So let's just give example. If just one more circle, so this coterminal angle will be 60 degree plus 360, right? So it's like a 420. It still can be have one more circle, so 420 plus 360 equals to 780, right? They can keep on doing that, right? So this can be, all these are the coterminal angle unless they are second line falls on the same place, same point on this circle. Yeah, so this is the conception. Okay, so thank you very much. Today we talk about lot of the conception of the trigonometry. So please review that not only based on this video, also based on the textbooks. Okay, so thank you very much.